Okay, today's lesson is the first one looking at multiplying and multiplication exponents, and first of all, multiplying in algebra in general. Um, so we have to cover a little bit of the foundations of algebra. Is that there's a famous quote from Galileo Galilei, who is a famous astronomer from, I'm guessing, 1200, something like that, maybe earlier. But certainly during the Renaissance time. And his quote was, "Mathematics is the language in which God has written the universe." Um, so, and in many ways, and in fact, mathematics is simply a language that describes science and the world around us. The key thing with algebra is we need to think about is it's just simply the grammar of the language. So, and that's the way I like to think about mathematics, is that we can describe things in mathematics that we can't describe in English. Um, you can't, you have to use numbers to be able to describe distances or probabilities or anything like that, because you don't get the level of accuracy that you could do in English. So the classic example is talking about distances in terms of near, far, um, all those sorts of things. We can use mathematics to use calculations to work out measurements to an infinite number of decimal points, and that bit's really important. So for us to be able to do that accurately, in the same way as it is to be able to converse in any language, you need to know the rules of putting it together. Um, and so in English, we have things like infinitives, tenses, relatives, adjectives, and all those sorts of things. And in fact, when we compare different languages, they have their own sets of rules as well. The thing is about mathematics, and particularly algebra, is that these rules are universal. You can't, if you anywhere you go in the world using algebra, it will follow the same rules or the same patterns. There's some small differences in the way we approach some of the rules, but generally it's pretty standard. If you pick up a Japanese history textbook, uh, you may not be able to read much of it unless you have a good grounding in Japanese. However, if you picked up a Japanese mathematics textbook, I'm sure there would be a number of things that would look familiar to you. So what you need to do in algebra as your base is to try and learn these things that are the equivalent of the pronoun, the verb, the conjunction, and all those sorts of things. So that being said, there's going to be words that I use to describe parts of algebra that you need to have a good idea of. Firstly, an expression. An expression is the equivalent of a mathematical sentence. An expression consists of one or more numbers, variables, along with one or more operations. So then the big question is, in the same way the normal sentence has nouns, adjectives, all those sorts of things. They have a certain order that they must go in, and that's so it could be understood in any situation. A variable is quite simply an unknown value, or a term that doesn't have any values. And we tend to describe them with letters. So there's 26 of the Latin alphabet that we use every day. Sometimes in some situations you will see Greek letters make an appearance, and that's so that we have more than 26 variables to choose from. There is some conventions within mathematics to use certain Greek letters to represent certain measurements or variables. So that's another thing you have to learn as well. Operations is simply the mathematical processes which you're familiar with of addition, subtraction, multiplication, or division. So they're the key building blocks towards an expression or a mathematical sentence. The key thing is you may never have thought about it too much, as you might hear me talk about an expression or an equation. For me to turn this expression into an equation, suddenly I need to give the variables a value. So if we just leave that as it is, a at z could be anything, or the variables could be anything. Suddenly, if I give this a number, there's only one specific answer for a, and there's only one specific answer for z. So suddenly I've changed that from an expression to an equation. So what is an expression? It's basically a rule for working something out. For example, we can write an expression to give us how can we work out the number of days in a given number of weeks. Now we know in words that we can work it out by timesing it by 7. So to represent that in algebra, what we can do is change that so that it's 7 times n, where n represents the number of weeks, and 7 is obviously that number we have to get, and we might go days are equal to 7 times n. You can do exactly the same thing, so I could say number of days, 7 times the number of weeks, and use those variables. They are interchangeable, and that's why it's important whenever you give a rule, you always give what each letter stands for. So another example, what would the expression be to work out the number of table legs in a classroom? So it would be the number of table legs, the number of table legs is the number of tables times 4. Now we can work that out. So for example, if there's 16 tables in a classroom, we know that 16 times 4, 64 table legs. So today we're going to look at one of the first things about multiplying in algebra is that generally we don't use the multiplication sign in an algebraic expression. You may hear me refer to this quite often. Mathematicians tend to be lazy. We don't tend to like to write too much. So if we can get away without writing something or making the equation smaller, they will do. So if we have an equation like this, where it's 6 times a, take away 7, plus 3 times b, what we do is we write it as 6a, take away 7, plus b. You may also see in some textbooks or in some worksheets and things, we use a dot to represent times as well, and that's acceptable. But generally, in most things that you'll be seeing, we will write it without the dot. Sorry, I should put the dot there. As 6a minus 7 plus 3b. Now, the reason why we can do that is that if you think about if we have 5 plus 5 plus 5 plus 5, that's equal to 5 times 4. Now, we have to have the multiplication sign in this scenario, and that's because if we remove the multiplication sign, what we would have is 54, and that obviously wouldn't represent what we've got when the answer actually is 20. So writing 54 wouldn't work. Even if we wrote 5.4, 5 times 4, that kind of looks like 5.4, so that's not right either. But in algebra, numbers and variables, or numbers and letters, are different. So we don't have that problem of being confused by having numbers without an operation between them. So what we can do is 6a is actually 6 times a, or in other words, a plus itself 6 times. So what that means, and what your first task is going to be from the textbook, is simply writing the expression without a multiplication sign. So that's relatively simple for the first one, is it's 7t, not 70, but 7t, take away 3. It's part of the reason why t is not always used as a variable very often. If you've done science calculations with distance and time, you'll see t's used there. But in scenarios like this, if I'm having to converse with you and I say 7t, it might get confused as 70. The other one, the second one, we've obviously got 2 times is there, so we can get rid of them there. So you can end up with a combination of letters. So it's M, N, Z plus 3. Okay. The last one, we've got 5u times t. So we can get rid of that as well. We end up with 5u t, take away v. So it's a very straightforward start to looking at algebra. If you could go back to your OneNote and give that a go, please.